Okay, so here's one more example of area between two curves. This is number 52. I think we started to work on this one at the end of the hour, the last time we had school, which was a while ago. If you hear screaming in the background, that's because that's what happens on a snow day. As you remember, we recently learned that the way we find the area between two curves is we integrate the new function, which is the top function, in our case 1/2 secant squared of t, minus the bottom function. For us, that's -4 sine squared of t. So that guy down there is squared. Okay, so this is what it would look like for us. We'd say that the area, A, is the integral, evaluated from -π/3 to π/3, of our top function, f of x, 1/2 secant squared t, minus our bottom function, which is a -4 sine squared of t, so that's +4 sine squared t dt. Okay, now the antiderivative on the secant squared of t is a slam dunk. You've all got that one memorized. So we're talking about 1/2 tangent of t, and we'll evaluate that from -π/3 to π/3. However, the antiderivative of 4 sine squared of t is a little more complicated. We need to change that to the double angle formula, 1/2 times 1 minus cosine of 2t, to evaluate that one. Well, the 4 times the 1/2 makes a 2. Oh, by the way, this is from -π/3 to π/3. We evaluate this, let's see, 4 times 1/2 is 2, so this is going to be +2 times the antiderivative of 1 is t, and with a little work and maybe some u substitution, the antiderivative of negative cosine 2t is minus 1/2 sine of 2t. And we'll have to evaluate that from -π/3 to π/3. Now, you're not going to really notice, but I'm going to hit pause here and double check and make sure I did this antiderivative right. So it looks like I'm on the right track. Let's go ahead and evaluate here. I'm going to deal with this tangent thing first. I don't know why I don't have an over 3 right here. Okay, you've probably been laughing at me about that one. So tangent of π/3 is, so that's going to be 1/2. This thing's not writing for some reason. I guess because I don't have the ink on. There we go. 1/2 times tangent of π/3 is the square root of 3, minus tangent of -π/3, which is a negative square root of 3. And then over here, when I plug in π/3, I of course get π/3 for t, and the sine of 2π/3 is square root of 3 over 2 minus, so it's going to be minus 1/2 times the square root of 3 over 2, that's square root of 3 over 4. When I plug in a negative π/3, I'm going to get negative π/3 for t, and the sine of negative 2π/3 is negative square root of 3 over 2. This is going to be plus square root of 3 over 4. And so a little simplifying ends up with the following. Right here, we get the square root of 3. We get 2π/3 minus the square root of 3 over 2 plus 2π/3 minus the square root of 3 over 2. The square root of 3 terms actually cancel, and I end up with, I'm going to draw it right here, the fraction 4 pi over 3. Whew. Alright. So that wasn't perfect, but hopefully that gives you an idea of the strategy here to figure out this shaded area between these two curves.